to the Istio Networking community meeting. Today we will have a few follow-ups on previous topics, notably the proposed names for the multi-cluster implementation. I'll also, like Vadim is with us. A bit later, I'll follow up on some TOC response, and we'll also go a bit over the GitHub epics. So I propose we start with your topic, Vadim, the multi-cluster naming.
Start. Okay. Can you see my screen?
Yes.
The document? Okay, so to provide the context, in a production environment, you can have multiple clusters connected together, okay, and clusters could be on different, on the same network, on different networks, in different clouds. You can have, for example, compliance regulations. For example, some applications have to be on different networks, and so on, and you can have multiple clusters. And these clusters can be connected by different patterns, let's say. And currently we have 3 different examples that describe these 3 different patterns. And what I propose is to give these patterns or these examples, some catchy names. Like, for example, for design patterns, we have builder and we have visitor and so on. Let's just decide on the names for the cluster connectivity patterns, let's say. Okay. So there are 2 aspects in cluster connectivity. First is network connectivity. We have either pod-connected clusters. The meaning is that pods can connect. Pods from one cluster can connect to pods from another cluster. So it's called it's so-called flat network or VPN connectivity and so on. So basically, simply saying it's pod connected or pod to pod connected clusters, or you can have gateway connected clusters. That means that gateways, let's say egress gateways from one cluster can connect to ingress gateways of remote clusters. Okay. And there could be some, let's say, optimization that pods from one cluster can connect to ingress gateways of remote clusters. So the first aspect is network connectivity, and then we have different, let's say, deployment patterns.
Sorry to interrupt, Vadim. On this topic, what do you mean? I'm not entirely sure how you are going to use it in the documentation, how we are going to use it, because in reality, Istio Mesh support both in the same multi-cluster. So you can have a multi-cluster environment with 20 clusters, 5 of them on a VPN, another 5 on another VPN, and the others each in its own network.
Exactly, yes. This is what I'm talking about, what you are describing.
So we are saying that Istio Mesh supports multiple networks. Each network consists of a set of clusters.
Right.
It's not one or the other. It's always
exactly,
both.
Right.
Okay.
Right. Yes. So talking about each pair of clusters, you have different network connectivity between them, and you have different deployment pattern, let's say. Or talking about groups of clusters or clusters of clusters, let's say.
And I think for this particular subject, I think we already have an APIs in mesh config and where we define the networks, and we use the term networks to mean a set of pods in one or more clusters that share connectivity. So there is an API that already have, and we call them networks for some reason.
Mm-hmm. Okay.
Can we keep the name networks as we have in the API, so we don't have to rev the API again too?
Yeah, that's fine. I'm talking about documentation now.
Okay.
What we document, on the Istio site, how we call these patterns, like some simple catchy names, so the developers or users can, relate to these names and they can talk one to another. Here I use that pattern, here I use another pattern, and so on. Just clear names for the patterns.
Yeah, no, I agree with you. The problem is pod, for example, implies that it's Kubernetes. That's not really a good start. So names are always typical.
Yeah, we are talking, I guess. Okay.
Anyway, sorry.
Clusters. Yeah, multi-cluster. Okay. So we can talk about container connectivity versus gateway connectivity. Maybe
VMs.
Yeah, no, we don't want to do that either, right? I mean, we're going to encompass VMs too. So.
And Android.
Yeah, okay.
So we could say something like direct connectivity, right?
Okay, so the first aspect is network connectivity, and the second one is deployment patterns. So here we came up with 8 different names. So basically it's about either we have shared control plane or we have multiple control planes, or independent or decentralized or symmetric clusters, let's say. So here the names are basically about either we are talking about clusters, primary, secondary cluster versus peer-to-peer or symmetric clusters, or we are talking about control planes, either shared, centralized, or independent, decentralized, distributed, multiple separate local control planes. So, yeah.
One more data point here from Environment Working Group. We are in process to support multiple control planes in a single cluster, and we call them environments. So that's kind of a generalization of you can have multiple pilots with different configurations, but they operate in the same kind of, and it would be wonderful to keep them aligned.
Okay, right. So a remark here is that share doesn't mean single. So you can have multiple shared control planes. They can be, yeah, and even in the same cluster, we can have multiple control planes.
I think the point was one control plane is defined as a set of, not of echo, sorry, as a set of configurations. One particular environment basically has a particular version of pilot, a particular version of everything, and that particular environment may span multiple clusters. That's and it is not necessarily that it runs in one cluster. It may run completely outside of any cluster. It can run on a VM. You just have pilot and some stuff running on a VM outside of any cluster, or you can have it in over the node. I mean, that's kind of how you install it, not necessarily how it's logically organized.
Okay, I see. And we have a table of different implications. But this one, I guess we can at some point publish this table to describe, let's say, to describe to the users reasons where they should use each pattern. Okay, so here we have some we disagree on different points, but let's say there are some practical implications. So, for example, in one settings, the operators, let's say, have to provide and configure access to Kubernetes APIs. So they have to configure sidecars to communicate with remote pilots. In some cases, you have to create and replicate either Kubernetes services, or you have to create Istio service entries. You have to install a DNS server, for example, in some setting. Okay, so here we can do it later. This implications table, let's say, with options to describe the options for the users. But first, I propose that finally we somehow decide vote. I don't know on the names. So these are the current names, 8 options to choose, and I don't know what should be the process. How should we proceed from here?
Can we avoid the decision by just not using multiple names, just using one name? It's multi-cluster and you have choices on how you deploy, but that's not relevant to anything.
Yeah, so this is what I propose. How do we call these deployment options? It's all multi-cluster, right? Multi-cluster mesh. That's agreed. What is not agreed? How do we call these deployment patterns?
But what is really the difference between them? I fail to understand the difference, because in a mesh, in a multi-cluster mesh, you can have both at the same time. So it's not really I don't really see why there are two cases. It's one case, and in that case, you in a multi-cluster mesh, you can have both type of network and both types of whoever you want to call it. I mean, having one cluster where you have a pilot running and using only gateways and using what you call the second method, and all the other cluster using the first method. Or you can have half of half. Or you can have each region use a particular a shared control plane with multiple availability zones, and then you connect to the other availability to the other regions. So it's a mix of options that used as a continuum across a deployment.
Right. So in the discussion before, we described the various options for bridging networks as just multi-network, right? And we kept multi-cluster and multi-network as two separate topics. And in part, that's the reason why the API is structured the way it is. Right? It allows us to talk about those two things independently.
And I would say that really the second part, I mean, how you organize a control plane is about how you bridge the networks, not how you deal with multi-cluster, because in reality, the pilots in each network need to have visibility into that network. So if you organize with the second option, what you call peer-to-peer, each peer is really a network with its own locals that is with a pilot that is managing that particular network. I mean, it sees all the endpoints in that network and can only load balance within that network. You can you can also have a mix where you can have a pilot that is having visibility into all the networks across the entire mesh, but you still use this kind of pilots that are local and only have visibility into the local network as a failover mechanism. So the two mechanisms can be combined and should be combined and used together in a production environment, because each of them has benefits, and you should not sacrifice one or choose between them. You should actually try to deploy both of them, as much as possible.
Yes, right. As I said initially, so you can have multiple, like 20 clusters. You can have multiple networks, and you can have multiple patterns applied between different clusters. This is agreed, I guess. Okay. So what is left is just to give names, catchy, simple names to these patterns. Okay. First, second. Also, in the pod-to-pod connectivity on the same network, you can decide to use gateway connectivity. So you can still decide that for some reasons, for more control, you still direct all the traffic. You use split horizon ADS, and you direct the traffic between the gateways. Okay. So we have these issues. I claim that they are orthogonal. So you have network kind of orthogonal, let's say. So you have network connectivity here, as you can see in this table, two options, pod to pod or container to container, and you can have gateway connectivity. And then you can have these three patterns, which you mix, which you apply in different cases, okay, in a production environment, and you mix between them. So what is left is just to give them names. That's all. Simple names. And here, these are names for a deployment option for these patterns. It's not like the whole mesh. It's this. Here we apply, for example, primary, secondary cluster connectivity or deployment, and in another case we apply peer-to-peer deployment, cluster deployment.
So Vadim, when you say primary, secondary, are you referring to the control plane?
Cluster. So here I refer to primary, secondary cluster, and the idea is that primary is the one that has a control plane, and secondary clusters use this control plane of the primary cluster. So here the names are, we either name the clusters, primary, secondary versus peer-to-peer or symmetric clusters, or we call the pattern by control planes, like shared versus separate control planes.
So is there any case where we even want to have a single control plane? I mean, as an example, in the documentation, it's wonderful to show how a control plane can be configured to see endpoints from all networks. But in a practical deployment, in a production deployment, is there any case where you'll have a single control plane?
No,
I think there will be cases, Costin, when there are people who are running
Sorry, I mean a single instance of the control plane, not replicated, because you always should have a set of control planes to solve the high availability. I mean, may run in multiple zones, multiple regions, and so forth. So
right, that is implicit, but it's about, so it's not about how many instances of pilot you run for horizontal scalability, right? It's about how many, it's about sharding. It's about...
No, not sharding. I was not about sharding. I was talking about the fact that it always should be in multiple availability zones and regions.
But that doesn't mean that it's multiple control planes.
Exactly. It's not multiple control planes. It's one control plane logically that may run in multiple clusters or multiple availability zones. But it's not.
You can also do that within a single cluster where your cluster spans through multiple availability zones.
Yes.
Exactly.
So by the way, I'm not sure if you guys seen it. We did a survey on multi-cluster deployment model as a community, and we published the result of the survey probably a month ago to discuss the Istio.io. And surprisingly, I think a slightly larger chunk of the users are more in favor of using single control topology with split horizon. And there's also sufficient large amount of users are interested in gateway connected control plane, multiple control plane topology we have. So I think both are interesting for sure.
Yeah, maybe to clarify here, there is no word single, so it's shared control planes. There is no single control plane here.
Well, that's a statement today because we only pretty much support the install Istio into one namespace. Yeah, you're talking about the future. So when we run the survey about a month or two ago, that's all we support, a single control plane with split horizon or with VPN connectivity.
Maybe we can rename the single control plane to master control plane?
No, they're all peers. They're all equivalent. I mean, it's one set of configuration. The main distinction, I think, is if you see one consistent configuration in all the mesh, or if you are seeing a disjoint configuration.
Right. Because so it's a global deployment with a regional shard, right? With regional replicas, right? That would be a typical deployment.
Yeah, and also remark, I think that split horizon is just an implementation detail.
And I would say even gateway, connecting via gateway is also implementation details. That's part of the networking and how network happens to be implemented. It doesn't matter how you organize a control plane. It should support both modes always.
Yeah, so Vadim, I don't know if you looked at the doc I wrote a while back about this. Actually wrote quite a long doc.
Yeah, I read your doc, yes.
Right, where there's either a global control plane or a federated set of control planes, and then there's the distribution of control plane replicas, and then there's whether you're a multi-network or single network, right? And then that's gateway connected, multiple VPCs, but that's a kind of tertiary detail in your decision-making process.
So Louis, it seems that the right naming would be global control plane, not single, not master, correct?
Yeah, for the control plane, it's either global or it's federated, right?
Okay.
But global doesn't necessarily mean there is only one. You can still have a global control plane.
It has nothing to do with the actual deployment of the control plane bits. It's just talking about one mesh versus many meshes.
Yeah,
right? You could say global mesh versus federated meshes.
Yes, but here we are
talking, what I said.
Sorry, here the whole document I am talking only about the single mesh. It's not about federated. So we have
right, but then we have to make sure to use terminology so we can at least distinguish, right? Because there are definitely as many people, like to Lynn's point, people out there where they're going to run each mesh separately, and then they're only going to bridge subsets of the services.
Right.
Right. So it's an extreme form of split horizon.
Actually, that's a very good idea. If we are saying split horizon networking to refer to the to connectivity through gateways, because that's what it does. It's also a split horizon config, really, we're talking about. Because right. in the multiple control planes you are describing here, you really have a split view of the configuration. In one case, you see some service entries, in another case, you see several different service entries, and the actual rules can be different. Does it
Right,
make
yeah.
sense?
For bigger customers, I think that's actually what they'll end up doing.
Yeah, still to clarify, the whole document is about multi-cluster service mesh. It's not about your second option of federated meshes. So when the users want to deploy a single service mesh, multi-cluster service mesh, they will apply different patterns.
So what I was saying is, in this context, they will have the option to deploy. I mean, they will have a split horizon networking, either one network or multiple networks with different view, and they will have split horizon or single horizon control plane or configuration. So the configuration can be either single set of data across, doesn't matter where you put it, but it's the same configuration everywhere, or it can be a split horizon configuration where different parts of the mesh will see slightly different configurations. They may see different sidecars, different rules because they are localized basically. So I think that's the main distinction here.
Yeah, but again, this is the implementation distinction. So for the users, I think what is important is implications. So either you have to replicate Kubernetes services or you have to replicate Istio service entries. You have to provide the access to Kubernetes APIs or not.
But I think that's implementation detail. I mean, that's something that operator and the config system will take care of. I mean, that's something that user will not see. What the user will see is
the users of Istio, the operators.
No, the automation tools that we are building. I mean, the whole installer and Istio operator and all the tooling that we are building will hide all those things from the user. What user will see is either one configuration that is consistent across the entire thing, or he will see different configurations. That's the only user visible difference that they will have.
Yeah. So,
Costin, go ahead, Wade.
So I'd like to figure out, what is the order of determining the layout that the customer is going to make, right? What is the first piece of information that they want to understand in order to make a decision about how they're going to do their deployment, right? Is it the network topology? Is it the organization of clusters, or is it their administrative domains? Right?
It's all of them.
I understand that all three factor into the decision, but which one drives most of the decisions?
Well, networking and admin control are clearly something that cannot be changed, and they are fixed and you cannot avoid them. So if you cannot have a flat network, you don't have a choice.
Yeah.
And if you don't have a single administrative domain, again, you don't have a choice.
Right, but I would say the administrative domain is the most important, right? Because you make a choice based on that, and then like for the network, you go with whatever is recommended, right? If you have multiple networks, you will have to have split horizon.
Right, but remember that when you deal with any one individual, they're probably thinking about their administrative domain first, right? If what we're trying to do is pick terms of art, right, that resonate with people and they understand easily, right, then aligning with their decision criteria is probably the best way to go about choosing the names. Right. So the other way to do this, by the way, is to pick fairly recognizable names for what we would consider the most common use cases and give them names. Like, for instance, I have multiple clusters and they all have their own networks. I've heard that described as archipelago mode, right? Which sticks with our nautical terminology. And then you could describe that, and right, you could outline what that use case looks like, and then you could talk about some variation within that use case, right? Without trying to have a kind of perfect ontology of multi-network, global versus single mesh, federated, non-federated, right? All those dimensions, and try to lay everything out in a grid. So that's the other way of approaching this problem, right? Is not to do it by matrix. It's just, let's pick the common use cases and give them names that resonate.
Mm-hmm.
Yeah, so I think single with federated mesh resonate well with the mesh admin, right? So if I'm a mesh admin, I'm in charge of my single mesh. And if there's multiple meshes, I assume it's multiple mesh admins.
I like Louis' proposal with Archipelago. I think that's a really sticky name, and I've heard this. It resonates with me at least.
Right, so our Archipelago is single mesh multiple network, right?
Yeah, exactly. And so I think, so Louis, I hope you do agree we have to get rid of the cluster-aware routing. And I think the other one is not too bad, but we have now cluster-aware service routing, which has nothing to do with the...
We definitely need to fix the terminology. Like,
yeah.
I don't think there's an argument with that.
Right. Gateway Connected is not a bad name, but I think Archipelago would probably be kind of, you know, a better name for that case.
Well, you could always have more than a name, right? You could say, you know, Gateway Connected, i.e. Archipelago mode, right?
Yeah.
Multi-network that we used before is not so bad.
Yeah, multi-network is okay. I actually don't mind that. We can talk about the control plane deployment topology in terms of availability, right?
Right.
Right. It's almost like we could separate that as a separate topic and just say, look, here's how you plan for high availability.
Yeah, this is the first row in the table.
Yeah.
But we have some agreement with the Shriram. Yeah.
If I can add one requirement, any name we choose should be easy to spell. Archipelago, I'm not entirely sure how many L's and...
Yeah, I don't like the pronunciation being too hard sometimes. I wanted some names easy to spell, easy to actually pronounce.
That's fine. Like, it's okay to have more than one name for a thing, right? That one is a descriptive name and one is a metaphor. Because that's what Archipelago is, right? It's a metaphor for the
Yeah, but I disagree that we can have multiple names. I think we should all stick with one name. We have like enough concepts that, you know, people need to get familiar with. So the fewer new names and the fewer confusion we see, the better.
I agree. I mean,
Archipelago, guys, come on, please.
But if we have to stick with a single name, then the one we have is perfect. I mean, I think we don't need to worry much. I mean, multiple network is clear, easy to understand. For that part, I think we should stop worrying too much.
Yeah, I think I would tend to agree with that.
Agreed. Single versus multi-network or intra versus inter-network.
Okay, sounds cool. It looks like we have a decision. Based, I guess, on people who spoke, like if there are 27 people on the call, so if you have an opinion, please say it.
Can we write down the decision? Is it I'm not sure if I heard it correctly. Is it a single mesh, single network, single mesh, multi-network, and federated mesh?
So those would be the primary, I think, yes.
Okay.
I'm not entirely sure what federated mesh means, to be honest.
Two separate.
Isn't that the gateway connectivities?
It's two administrative planes, Costin.
Right. It's two mesh admin, more than two could be.
So it's peering, right?
But,
you could call it mesh peering, actually.
But would the multiple environments that we're adding for single cluster be a federated mesh? Even if you're in a single cluster, we still have different admin domains because each namespace.
No, that's single mesh multi-network with split horizon.
No. That's single cluster, single network, but you still have multiple admin domains. I mean, staging, production, and so forth.
I don't think we need to distinguish that. We could just put that into. I don't think we need to name that. I think we just need to describe it.
Okay.
It seems to me that where the systems run that provide multiple administrative domains is irrelevant, and whether they run on the same cluster or not doesn't matter. So you're either talking about one or multiple administrative domains, which may be represented by multiple deployments of Istio.
Which really don't have to run in any cluster whatsoever. I mean, they can
run on the same cluster or multiple clusters. They can run on VMs or bare metal. It doesn't matter.
Right. That's exactly why it's coming together to use mesh as the terminology was control plane, which is what we had before.
Yeah, control plane is a deployment implementation detail, whereas are we agreed that mesh is synonymous with administrative domain?
I think so.
So Edgar, when you say that Kubernetes has already given a name to that thing, what thing do you mean? If you're referring to multi-cluster, right, they refer to multi-cluster as a means to do unified scheduling across many homogeneous Kubernetes clusters, right, which is a little different than what we're trying to achieve here.
Yes, indeed, I was just referring to the multi-cluster setup.
Right.
Because, well, at the beginning of the call, you were talking mainly about the well, you were talking about multi-cluster in the base Kubernetes setup. So I was still thinking about that kind of configuration.
Yeah, so just coming back to the names, right? Obviously, single mesh, single network is the kind of the simple example, and we could just refer to that as mesh, right? And then if we would refer to single mesh, multiple network, you could just call that multi-network mesh, right? If you're looking for synonyms, right? Because we're probably going to have synonyms that people are going to use in kind of paragraphical contexts when they refer to these things.
Yes, I still have a question regarding single mesh, multiple networks. So we still have two different deployment patterns here. So we can have multiple networks, single mesh, and we can have either shared control plane or we can have multiple control planes.
So that becomes federated. So it's federated single network, federated multi-network.
Well, Justin, I want to be very careful and reserve federation to mean multiple administrative domains, distinct from split horizon.
Agreed. But you can have multiple administrative domains, but still use split horizon and gateways. I mean, the network is orthogonal to.
I know, but like in the naming hierarchy, what you might say is split horizon multiple network, right? There would be a separate.
Do we need to say split horizon multiple network? Because
Well,
the only way multiple network is implemented is via split horizon.
It's not actually. You could. It might not be split horizon, right? Everybody might see everything else.
Oh, I see what you're saying, but that's still a. It's a very very narrow case, right?
It's not a narrow. It's a best case scenario because if you see everything, you have the best load balancing. So ideally, you should see everything as much as possible in order to make good decisions about assignments.
Right. I don't think this is about load balancing so much as service visibility.
So shall we call it maybe global view versus something else?
No, I would just
single mesh versus multiple mesh.
But it's different than multiple meshes. It's still within the single mesh case. You can have multiple networks and you can still have the control plane have like global visibility of all the networks.
That sounds like single mesh.
Yeah, it is single mesh still.
What I'm saying is that when we're talking about the use case where you have multiple administrative domains, you have not all services available to not all other services, that another way of saying that might be multi-mesh or federated mesh.
Yeah, that is federated mesh.
Yeah. Can we actually agree that federated mesh equal multi-mesh?
Well, by definition, it does, right?
Okay.
So then we have a 4x4 matrix of single versus multiple mesh and single versus multiple network.
Effectively, yeah.
One thing we have used in the past was to say that a mesh equivalent with a identity domain, meaning trust domain or root CA.
Right. Names also, I guess. Names.
Yeah, that typically aligns with administrative domain. Right?
Not really, because you could have a single root CA. I mean, one large organization which shares a root CA and everything trusts each other and trusts identity, but have each team manage its own. So it's federated, but
right. But then it's a hierarchy, right? So they still have to choose. They have intermediate CAs, and they choose whether or not to trust each other across those intermediate CA boundaries.
Well, if you have a root CA, you kind of trust everything.
No. You know how to verify the identity. You don't. You haven't made a decision about whether to trust it or not.
Maybe.
Yeah, still. Talking about a single mesh, okay, we have a common root CA. We have the same names, we have the same administrative domain, but we still can have a control plane in each cluster. I guess this is what's related. So how do we call this pattern?
So, Vadim, it's not that you have in a single cluster, is that you can have different views of the configs in each cluster. It's a
The cluster is irrelevant. Cluster is a host topology.
Yeah, you can have different views of the services.
Okay.
Right? So and that's what we call split horizon.
for config.
Okay, so how do we call the non-split horizon deployment?
Single mesh, single network, or single mesh multi-network.
Yeah, so I don't think split horizon is a refinement of single mesh, probably in the case of single mesh multi-network, right? But I don't think we need to give a specific name to without split horizon single mesh, right? So split horizon is a refinement of single mesh.
Right.
It's a subtopic.
Yes, right. Yes, agreed. Split horizon is a refinement of a single mesh. However, we have additional deployment pattern implemented by Shriram for a single mesh, which is not split horizon.
It is really split horizon if you think about it.
What Shriram implemented?
Yeah, it's effectively a split horizon config.
Yeah.
Which one, Vadim? Which one are you referring to? The gateway connectivity?
Right.
Or the endpoint split horizon by network.
Horizon.
Split horizon config.
Yeah.
No.
Are you talking about the network ID?
Yeah, let me open the current documentation on this too. Let me show you what we have. So currently we have two different examples. First one is called cluster aware service routing using Istio split horizon DS. This is what we have, a single pilot here, okay, and pilot has access to Kubernetes API server. This is the first example. Okay,
split horizon network and single horizon, whole horizon control plane.
Yes, I guess designed by Kostin and Yossi, okay, and Yossi implemented it, right?
Yep.
Yeah.
Okay, so here we have additional deployment setting. It's called Gateway Connected Clusters, implemented by Shriram. Let me show you here. So here you define these global service entities. Okay, you deploy a DNS server and you have multiple control planes. It is still a single mesh. You have root CA, you have the same names. Okay.
And the config should be more or less similar in terms of RBAC and everything else, but it's split horizon because each region or each set can see a different set of configs.
So they are both split horizon. The difference is one has a single control plane and the other has a control plane in every cluster, right?
No.
So I think this is like we talked about the 2x2 matrix, but I think we actually have the control plane matrix as well, which is quite orthogonal. And
So
we should probably handle it separately.
Andra, in both cases, you can have a control plane in each data center. So the difference between the two architectures is the first one, all the control planes see exactly the same config, no matter where you are. In the second case, you see different configs. I mean, in one case, you'll see a service as a service entry. In the other cluster, you'll see it as a normal service.
Okay, so in the first case, it's you read the pilot reads the Kubernetes API server directly,
or synchronizes through whatever CI/CD system and see exactly the same config, exactly the same thing everywhere.
Mm-hmm.
It's not split. You can deploy a control plane everywhere, but it will still be based on the same configurations.
Right. You can still see the same config. The other means than reading directly from the
whatever
Kube API server. You know why? I actually opposed in the past to this method because it involves like, changing your kubeconfig file to access other kube API servers over.
That implementation detail, right? Let's not worry about it. It can be implemented in many ways, but the end result is you see same config or different configs, pretty much.
Yeah. So my question is, how do we call these two different implementations or patterns? I mean, the one is of Yossi and Kostin, the other is of Shiron.
I'm actually for like completely dropping the one where we read from the Kubernetes servers directly and proposing the model where we use I think it's the gateway connected.
Why?
So just to drop the model?
Because the first one still looks like a hack to me and nobody can convince me it's not a hack.
Well,
it involves really
everyone
editing your kubeconfig file to put there the secrets for the other cluster. The pilot becomes very busy reading from multiple kube API servers. It's just not, it doesn't seem scalable.
It's like, and Andrea, the only distinction is how many boxes sit in between the arrow, between the control plane and its source of information, right? So I really don't want to go into that, right? We have to focus on, the use cases here and what use cases we think people are going to look for when they deploy.
Given that it's only a solution that has been tested in production and it's most stable, right? Says that data suggest.
Okay, let's not focus on what's stable either, right? We want to be forward-looking, right, and pick stable naming that's going to survive even if the internal implementation details change.
So how about we stop? We merge them basically. We say that it's a one multi-cluster, supports both split network and split config.
So the other way to do this, right, is to say we have mesh peering, right? But I don't think we want, right? And the reason why we would do that is that we wanted to recommend people run one control plane per network. But I don't think we want to say that.
It doesn't necessarily have to be one control plane per network.
No, I know it doesn't strictly have to be, but that would be the typical pattern, right? And the reason why you would do it is because you were worried about network partitions. But I don't think that's a better set of terminology than the ones that we just mostly aligned on, I think.
For me, this is very much an implementation detail, like how we learn about those services. It's not even like different config, because in both cases, you can have the same config or different config. Like Pilot can learn about services in another cluster directly via, peering with another Pilot, not necessarily like, or from MCP, from Gale directly. It doesn't need to read the kube API server. So, I mean, I wouldn't even get into that level of detail. How does Pilot discover the services in another cluster?
Louis, I like what you suggested before in that that whether you're running multiple deployments of Istio or not is just part of the HA question.
Yeah,
and it doesn't need its own name. It's somewhat orthogonal.
Right. We just call that deployment topology choices.
Yeah.
Right.
Maybe.
So then we don't go into the details of documenting, the
No, we do.
API part.
We just separate the two topics. We cleanly separate the two topics.
There's going to be a continuum of how far you want to go to make the thing redundant to multiple levels of failure, and they all don't need their own names. It's all can be grouped under documentation that talks about high availability.
Yeah. So we just have we have mesh topology and we have deployment topology, and those are two fundamental topics, and they can be treated right. One informs the other.
Yeah, there is another implication here for the users actually. Okay, so in one implementation, the remote and local services, they are named, in the same way, and they are load balanced together. So the local version and the remote ones just load balance between them. In the second implementation, you have overriding. So if you have a remote version, this remote version is called. Once you define a local version with the same name, the local version will override the remote name. So it's still,
That's implementation detail, Vadim. I would say this is implementation that we can fix this eventually, even if you have, we still allow overrides, But in the second case, we could still have a global view and make better load balancing decision. We could still take into account, and there are different proposals to do that. It's just currently not implemented.
Okay, I see.
I think the important opportunity here is to help users build a mental model. And what Louis is, and Costa and Andra are suggesting are higher level constructs to help people build that mental model. And where the control planes are deployed or how many you have of them are not as important.
So I recorded that, Shannon, in the meeting notes. The fact that we want to separate the deployment topology from the mesh topology. I hope that's correct. Please everybody review. And of course, like Vadim will update his document as well.
Mm-hmm.
Right, so when it comes to mesh topology, right, we either have single mesh or multi-mesh. There's a specialized use case within single mesh to split horizon. And then there's the control plane, the valid control plane topologies and the network topologies, which we should talk about. And then there's probably a document about common use cases that pull those together with recommendations.
Mm-hmm.
For the use cases, I think we have just a couple of them being documented. So, but federated multi-mesh, we haven't really implemented yet. So
Not clear what it even means. I mean, what is this federation? I'm a bit concerned that
it's use case driven discussion, right? That if you have a mesh and someone else has a mesh and they want to talk to each other, how do you set it up?
Yes, that's what I would call federated, where you
yes.
have completely different. You buy a company and that company has a mesh, and how you.
Like we don't care what
exactly.
the division of the administrative domain
is.
It's just they're different.
Yeah.
Yes.
So you
have different names for different services, and you have different CA routes.
That would be probably quite common, right? Yes.
And maybe different trust domains.
Mm-hmm.
Yeah, maybe not.
Yeah.
So sorry, just to go back to the single mesh, we have the single mesh, and we say there is a specialization for the split horizon. So
right.
That is for the single mesh multiple networks?
Typically, yes.
Okay, single mesh multi-networks. And how do we call the single mesh multi-networks that is not split horizon, that is the global?
We just call it single mesh.
Single network.
No,
well,
it could be
because I like more the split horizon, so it's kind of unfair to the to call that the specialization. I will call the other one.
So the multi-network single mesh, where everybody sees the other services equivalently, regardless of their network topology, I think we still call single mesh.
Yeah.
In the situation where they don't see the set of services equivalently, I think we call that split horizon.
Yeah, config split horizon.
One, it's better aligned with the terminology around DNS split horizon, right?
Mm-hmm.
And that's really the thing people are trying to achieve, because they're running services in different topologies, physical topologies.
Okay, I'm convinced now based on this analogy. So by definition, we assume everybody can see all the others, right? When they cannot, we're going to use the split horizon. Right.
For both network and config, I think.
Is that synonymous with multi-mesh? Or are we not using the multi-mesh term?
So the implementation detail of split horizon for services is massively overlapping with federated mesh, but I think we've eliminated, if you want to call that multi-mesh.
I would reserve the term multi-mesh for cases where you have different trust domains and different, kind of.
Yeah, it's probably going to end up with some confusion between federated mesh and multi-mesh.
Yeah. I personally find split horizon confusing. I can only think of a VM with two network interfaces. I don't know what it means in the mesh context.
I mean, the typical meaning is your DNS resolves name A to an IP, and my DNS resolves name E to a totally different IP.
And the two
the split horizon DNS, there is an equivalent in bridging. like in L2 bridging, there is a
Right.
split horizon there. So
There is that,
depending
yeah, I
from
know.
what world you're coming, it can have one meaning or another.
Right. So I'm okay with multi-mesh as a synonym for that. I
Split
think
horizon.
for split horizon around services.
Okay, but then and then we will have a federated multi-mesh thing to mean like.
Well, federation is by definition multi-mesh. Right?
Yeah, I see.
Then how do we call cases where you have completely different organization with completely different trust CAs?
That's federation. That's federation.
That's multi-mesh or federation.
Multi-mesh
It's the same thing.
Yeah.
Well, no. Remember, multi-mesh is the implementation detail. Right? It's you have different configs in different places. Federation is the description of the separation of administrative domain.
It doesn't have to be. We could define multi-mesh as being multiple administrative domains.
Not necessarily. So that's why I think what Louis is saying, we should basically replace split horizon with multi-mesh and also have federation on top of that.
But that will create other confusion because it apparently not everyone understands multi-mesh to mean the same thing.
So either way, we're going to have some confusion between these two things.
Yeah.
And we have to choose a refining term to describe the behavior of, look, it's a single administrative domain, but you are controlling where services are visible based on your own criteria, right? Because that's effectively what you're doing.
Yeah, I personally don't like split horizon at all. I think it has different meaning in different contexts. And if we can replace that with multi-mesh, that would be awesome.
So the problem I have with multi-mesh is, right, just the same reason we had a problem with multi-cluster and multi-control plane. Right, people conflate it with deployment topology.
Yeah.
Well,
and there are many other things. I mean, there's so much confusion about multi-mesh. I personally see it as different trust domains. I don't think anyone will comment.
I see federation as different trust domains.
Right. So if we can find a term that describes the behavior, which is the desire to separate service visibility by region or locale, without using the word multi, I would be all for it.
Split horizon doesn't have term multi.
No, I would say like either global view or some other view, if that's what you want. But
so
split horizon is not good costing. It's a very, very narrow term.
So you could say, well, it is widely used in DNS, right, for this use case. Yeah. But we could say service discovery, regionalization, or localization, or partitioning. Right. Either way, we're going to, right, it's not the primary term, right? It's going to be a refinement within the documentation. It doesn't have to be a first-class reference term.
How about adopting the term we use for multi-environment? I mean,
no, that's different costing because that refers to Kubernetes versus VM.
No. It refers to.
Louis, to go back to your suggestion of thinking about how somebody makes a decision about their topology and the hierarchy of these decisions, it seems to me one of the highest, if not the most highest hierarchy of these decisions is, am I one administrative domain or multiple?
Right.
And having a word for that is clear seems important. And I would suggest that at the bottom of the criteria we've been discussing is whether services can resolve to the same or different destinations. That seems like a feature which is true no matter what your topology is. And
I wouldn't disagree with that. I think in the when a person walks up to Istio, they're probably already thinking in terms of their own administrative domain, right? As the most common audience.
No question.
How about number 4, centralized versus decentralized, based on this comment? If you have a single IT department that controls the entire organization, you are centralized, and then you go with option 1. If you are, each team is managing its own.
Yeah. So I'm happy to use a term like service discovery partitioning or something like that, right, to describe the use case. And yes, it's a detail. I still think single mesh and federation are those are the two entry points into the discussion that
I like those too.
Administrative domain, that's the terms that I'm thinking it, right?
They are intuitive.
And then multi-network or single network is an implementation detail, and service discovery partitioning is an implementation detail of your mesh, as is HA.
But it would control your different deployment model.
Right, so it's going to inform what you're trying to do, right?
Yeah.
But if what we're trying to do is explain concepts to people, and then we're going to give them use cases that are going to help them make a decision about, right, what to choose, right, how to actually go to production. Right, so when we describe multi-network, we're going to explain why you might want to do it, or why you might have to do it, and if you have to do it, here's how you do it. Right, that's what you would do with an implementation detail.
But if you go to a customer, the first question is, do you have an IT department that is controlling all the network and everything, or each team is controlling? That's kind of the main decision factor in how we implement it.
Well, part of that conversation is also, do you need to coordinate with another organization who has their own administrative domain, or do you operate in isolation? And I would suggest that the answer that we operate in isolation is not as frequent as we think.
So but this is again related to the first part of the decision tree, right, Shannon? And I actually like a lot this. We should be able to produce somewhere this decision tree that people can follow and be directed, to a recommended architecture or recommended deployment model for them. I think this is very good. But once you are let's say you have administrative domain or multiple, let's say if the answer is one administrative domain, then how do we again name that service discovery difference? Because we haven't made a decision on that.
Yes.
Do we call that multi-mesh or not?
Or centralized. We can go with centralized. It's a perfectly clear, aligned with that.
Centralized, but not control plane. Centralized service registry.
No, control planes. That's what we are talking about. For multi-network, I think we agreed. Didn't we agree on multi-network?
But it's not about the control plane here. It's about the split horizon.
Split horizon for control, for configuration. So configuration can be centralized or decentralized.
Costin, I don't think people think in those terms. I think they think in the terms of, I'm only going to make certain services visible in certain localities. And whether it's one or 10 configs, right? But that's the terms that people are thinking in. So I think we want to use terminology that reflects that and not the detail of the control plane.
Yeah, you're right.
Thank you.
So, so I think, whether we use split horizon or, uniform service discovery or partition service discovery to describe the distinction, right? We can road test some of the terminology with users, and I can go to our UX group and ask them.
Probably that will be the best choice. Partition is a good one as well.
Yeah, so partition service discovery, I would be fine with that as a starting point. And if we get told, look, the users understand split horizon, then maybe we should shift. But
one thing I learned is that usually PMs and UX people are best to fix names, and engineers talking about it usually a waste of time.
Right, but we're just deferring, procrastinating, and making.
No, deferring to people who know what they're doing.
Right. So what we do is we'll pick names, right, and we'll list the synonyms for that scenario.
Yeah.
And we'll go and ask people who are not us.
Yeah.
Right, what their feedback is, and does it help them understand the use case?
That's perfect.
Okay.
Similarly, we should also list out what we think are the kind of top 5 real deployment topologies we think people will use most of the time, or top 3 and a couple of sub-variations of them, and document them.
Yeah.
Should we do a survey on this?
Yeah.
So that we can, so we can have our decision tree and the top 5 suggested names, so people can vote on top of that.
Yeah, I actually asked the PMs here to run it by customers. We have enough customers we can reach out to get feedback on this.
But do we have agreements that there are orthogonal issues? I mean, one is networking.
Yes.
Split or not, and one is okay, good.
Right, like so some of the things are documented in the meeting notes, but so basically just to go back to the like the service visibility. So we have a partial, was it partial service view versus global
partitioned. Partitioned.
Okay, partitioned service view.
Right, and you could say partitioned versus uniform or global, right?
Okay.
I think
so let me write that down.
And that's just the default behavior, because I can always using my sidecar or network policy or even RBAC to scope my services.
Right. It's separate from access.
Not for access. The question is for load balancing and visibility. I mean, do you see all the endpoints in their load, or you only see their gateways?
So it's versus.
Yeah. Well, I mean, even forgetting about the actual physical implementation details of the network, what are the reasons people partition service discovery? Right. It's to indicate to consumers what they can or cannot use in a particular regional context or physical locality context. So you cannot call, the US credit card clearing service from something in the EU.
That would be RBAC or some other stuff based on label.
Right. So it's more about helping people understand and recognize the allowed dependencies between services rather than the actual enforcement of what's allowed.
Right.
And this kind of use cases will be wonderful. For example, I have a data center in Russia, and I don't want to, or some other country, and
right, yeah. Right. People choose meaningful names for a reason. Hopefully.
Okay, so folks, we are actually 5 minutes over time, but I think we did make some progress on this. So thanks to everybody who really commented. I think it was a very productive discussion. So some actions out of this is, I guess, the UX study, right? So the PMs and Louis, should we ask some of the UX people at Google to do this kind of stuff?
Yeah, I'll work with Vadim on refining the nomenclature. Then we can run it by, I'll get the product managers to run that.
Okay, great, thank you. And like Vadim, I suppose you'll update the document based on everything we discussed, and somebody will have to go and change the Istio.io site, right? So we have to fix that documentation. So please feel free to open issues and just assign to people. Okay.
Well, let's wait until we've done a little bit of UX study, right?
Right, after the name has been determined. Then
Right. Okay.
Yeah.
I think not everything is really debatable. Some of the names
right,
are right there, right?
But just in terms of effort, right? This should be done as a sprint. So
okay.
let's until we resolve it, and then we can go and do this holistically, because we don't want to keep redoing it, right?
Yeah, and we look stupid to the community too if we keep changing our names.
Okay. Well, yeah, so we definitely have to, once we're settled, we should all keep using the same names, because otherwise people will be very confused. All right, so there were 2 more topics which I'm actually glad to have deferred for, for the importance of this topic related to multi-cluster. So they are not super important. We can follow up in 2 weeks from now, but read the the TOC response. It's in the document, and I also I opened the GitHub epics and put the link in there, so we can discuss in 2 weeks. All right. Okay, so thank you very much, everybody. See you in 2 weeks, and enjoy the rest of your day.
Thanks.
Bye-bye.
Bye.